Hello everybody, my name is Edward Rogers, and today in this video we are going to deal with a LeetCode problem, which is count negative numbers in a sorted matrix. And simply speaking, all we have to do is to count how many negative numbers within a matrix. So let's just get started. The language I'm going to use is Golang, so you can use whatever you want. And the method I'm going to use to solve this problem is a logarithm. And I assume that you understand, or maybe you have a little bit of insight into what logarithm is and the big O notation is. And these questions here is 2D arrays. So when it comes to 2D arrays, we are facing a typical issue in a big O square issue. So we have to use the method to reduce the iterations within each subarray, right? So that's why we use the logarithm, because we are going to iterate all the number sets within this big array and try to minimize the iteration within each number arrays here. So we are going to use binary search, right? All right, let's just start a code. The first we have to do is to assign a variable with the initial value of 0, which is counts, and return it. Right? Return. So it's going to return here, and then excuse me. And then, as we just mentioned, we have to iterate each number sets within the big array here. So for I, which is going to be 0, and if the index is less than the length of grid, the grid, then we are going to increment the I. And within this for loop, we are going to have a index fun variable, which is equal to the binary search, the result of the binary search functions. Binary, always spelling issue. And the first parameter we are going to paste things into the binary search function is the subarray, right? So each subarray. That is grid of current index, and the second is going to be 0, which is the target. So we are going to do to find out the biggest negative values within the subarrays, which is the value that is more closer to the 0, right? And then I am going to create a callback function, and the parameter. No, we are not taking the parameter here. And next, we are going to avoid if the return index and its value is greater than or equal than 0. We are going to avoid the counting action, right? So thus we have to check the current number set and its returned value from the binary search index found. If the value is greater or equal than 0, we are going to continue, right? And then, except this condition, we are going to add up the counting, right? So by doing this, we do, for example, like this. If we found this one, we are going to take this index and minus or subtract the entire length of subarray. But we can do opposite, like the length of current number set, and subtract by the index font. Yep, and let's just do this first, right? That's okay. All right, next we are going to create the binary search function. Binary search, and the variable taken is, the first one is a data rate. It's going to be the rate of int. The second one is the target, which is int, and the callback function, which is the function, and taking two parameters. The first one is the current values, and the second one is the target, which is int, and it's going to return the result if the condition is met. And then the result of final search is int. Alright, first, we have to declare a found index variable which begins at 0, and we're going to return it as our result, right? And with some here in between, we are going to iterate, or we are going to binary iterate each subset, number set. So we do, but first we have to find the lower positions, that is the first index, and the last position, that is the length of data set -1. And then if the first position is still small or equal than last position, we are going to keep the operation, right? And the first is first. As we said, as we just mentioned, we have to kind of divide the data sets into two parts. So we have to find a midpoint. So to find midpoint, we have to make lower plus height for the position issue. That is better to do this. Height and divide by 2. So lower plus height divided by 2. Right? And then we have to do a condition here. If the current midpoint, the value at midpoint is greater than target, so we have to do high. It's going to be equal to mid. I think it's -1 because it's getting backwards, right? Otherwise, is the first position, move the first position to the next position of mid by at 1, right? And I think everything cool here. Right, let's try. And the final step is to use the callback callback function to determine if we find what we want. So we have to check by this function. Taking two parameters. The first one is the midpoint. Midpoint. And the second one is the target. If the condition met, if this is what we want, we have to assign the mid position to the font. Okay, so that's what the index we want. Then we can return it. And next we have to create this function, the font callback function. The first one is data of int. The second one is, let's just call it current value of int. The second one is target of int, and then it's going to return a boolean, right? And all we have to do is to compare to the current value if that value is less than the target value. So that's the negative, or the negative value from here. All right, I think that's it. Let me kind of format it. All right, let's have a try. So we are going to put the first data set here, which has 3 negative values here. Let's front it. Runtime error, index out of range. Something would be wrong. Let me just have a check here. Oh, here. Yeah. All right, we've got 3 negative values from this case. Next one, I think there are going to be 1, 2, 3, 4, 8 negative numbers. Try 8. We've got 8, and the next one is 16. Right? Yeah, we've got. So let's have a try it into our LeetCode issue. Let me just run it. All right, accepted. Then submit it, and we can see the result. We have better performance. We can beat 82% of all assignments here, and the memory we're using is not too bad. All right, this is the video. I hope you enjoy it.